this tutorial, we're going to move, rotate and scale textures in Max. This video is going to be the first one in a series on some fundamental jit.gl.pix Codebox techniques. So these are techniques that I use all the time and that can also be seen in some previous videos. But the idea now is that instead of doing larger patches on specific visual effects, I want to showcase more general concepts. So each video will be self-contained, hopefully shorter than usual and more beginner-friendly. So this first one is going to be on moving, rotating and scaling textures. So the idea is that we're going to manipulate UV texture coordinates. So this video consists of 3 parts. In the first one, we're going to change the position of a texture. In the second one, we're going to rotate the texture. And in the third one, we're going to change the scaling of the texture. I will start with a jit world object as our rendering context. Here I have a jit.p window to monitor what we're doing, and here I have just a simple input video. I will start by creating a jit.gl.pix Codebox object. We can patch the video in here, and then the output can be patched in here. Okay, let's start with the first part, the positioning of an input texture. So if we just want to display the input we're getting here, we can say out1 equals input1, which just gives us the input texture we have here. But what is actually implied here is that we're sampling the input texture. So the implied thing is sampling input1 by the normalized coordinates we get in here. I will rename them here so it is clearer. So I will say that these are our UV coordinates. And when we're just looking at the UV coordinates by themselves, we can see that they're ranging from 0 to 1 on the x-axis. So if I'm just taking the x component, you can see 0 to 1 here. And then on the y component, 0 to 1 here. And if we combine them, we can see that the x component is represented in the red channel and the y component is represented in the green channel. So what does it actually mean if we do something like sample input1 by our UV coordinates? This tells us that we want the value that is stored at these normalized coordinates inside of this texture. So here we want to start with 0, 0. Here we have 1, 1. Here we have 1, 0. Here we have 0, 1. And all that is happening in between. And so in order to move a texture, we can just move these UV coordinates. So we could create a parameter so we can access it from outside of the patcher. Call this one pos for position. Then initialize it with 0, 0. So position 0 on the x-axis, position 0 on the y-axis. Then we can simply add this position to our UV coordinates. We can say UV plus equals pos, and then we're adding them here. So they are 0, 0 at the moment, so nothing happened. But if I am assigning them from the outside, I can move this. And you can see now 0 is starting here. And 1 is off screen. So if we then sample the texture again, so input1 by our UV coordinates, we can see that we've moved it along this axis. And as you can see, the texture is repeating here, but we could also specify different bound modes. So this bound mode essentially controls the behavior when we're going off screen, or when the UV coordinates become bigger or smaller than 1 or 0. So now we have bound mode wrap, but we could also say bound mode equals clamp. And if we spell it the right way, yeah, you can see that if we say clamp, then it will just take the leftmost pixel and drag it across the screen. The same thing here. And then there is the last one, which is called mirror. Then you can just see that when we're going over 1, this whole thing will just be mirrored. But I will use wrap, which is the default one. Okay, so now this is how to reposition a texture. Coming to the second part, rotation, this is a bit more complex, I'd say. So in order to rotate a texture, I will first create a parameter, call this one angle. Set it to 0 for now. So this will be the angle we want to rotate our texture by. There are different ways to do this. I like to do it using the car to pole function and the pole to car function. So the first thing we're doing is we're turning our Cartesian coordinates, which means coordinates that are defined by an x and a y position, into polar coordinates, which means that they are then defined by radius and by an angle. So we can use the following function, car to pole. Then we can plug in our UV coordinates. So uv.x and uv.y. And as an output, we get two outputs. So the first one is the radius and the second one is the angle. So we can say R and A equals the output of our polar coordinates. So now, we could also take a quick look at this, turn this into a vector, say R and A. Yeah, and this doesn't tell us much because now we're turned. So this is the radius. Maybe, yeah. Now it's better. So this is the radius. So the distance from point 0, 0, and this is the angle. So the angle from this point. So the idea is to change this angle or adapt this angle with our angle parameter and then transform them back to Cartesian coordinates. So we can then do something like x and y equals pole to car, which means polar coordinates to Cartesian coordinates. And then we plug in the radius and the angle again. And then we have to reassign our UV. So we can say UV equals a vector of x and y. So now nothing changes because here we have to apply our angle offset. So we can simply just add this angle here. Did this just throw an error? No, this is an older error. And then we can again change this from the outside. Here we have the angle. And then you can see that this thing is turning. But this expects angles in terms of radians. I want to change the angle in terms of degrees. So we can simply use the formula or the function radians. And then this should be in degrees now. Yeah, so 90 degrees, 180 degrees. Yeah, but as you can see, we're always turning from this point up here. So this is always the anchor point in order to turn this. In order to change this, we can create another parameter, call this one anchor, and set this to 0.5, 0.5. And in order to apply this anchor point, we have to first subtract it from our UV coordinates, then we can do the transformation, and then we can add them back in. So we can do something like subtracting the anchor here. So minus anchor. So now we shifted it to the left. And if I'm turning it now, you can already see that is happening from the middle point. So after we applied the rotation, we want to add this back in. So we can say UV equals X and Y plus our anchor. And now you can see that we're rotating it from the center. We can again access this from the outside and change this anchor and rotate it from somewhere else. But we're not quite done yet, because you might notice that as we're rotating it, it's also weirdly distorting. And this is happening because our aspect ratio is not 1:1, but it's 16:9 at the moment. So we have to take the aspect ratio into account. And in order to do that, we can create another variable, call this one ratio. And then we can take the dimension of the X component divided by the dimension of the Y component. For our X component here of this vector, and for Y we can just say 1. So this is going to be 1, and this is going to be a number that's bigger than 1, depending on the ratio between those two numbers or between those two dimensions. And in order to factor this in, we have to multiply our UVs that we're creating here. So we can say multiply by a ratio. And then we also, so now you can see that we have a square, but I mean, it's not distorting anymore, but as you know, the input wasn't a square. So after we have done our rotation, we can factor this one again. So where to apply this? Okay. Then we divide again by our ratio, and then we should have the original aspect ratio. Okay. So now you can see, even if we're turning it, it doesn't distort weirdly. It stays the same. Okay, so changing the position, rotating it. Yeah. And of course, the order of operations matters here. So if you will get a different outcome if you first change the position and then rotate, or if you do it the other way around. Okay, that's it for the rotation. Now coming to the last part, zooming into the texture. So we can create a parameter, call this one zoom. Let's set it to 1 for now. And the idea is that 1 means that we just have like the original image, and then the bigger this number gets, the further we're zooming in. So we can just apply this zoom. Where do we apply it? I think, yeah, before we change the position. So if we divide this one by our zoom, then we assign it from the outside and it should already be working. Okay. And of course, the anchor that we introduced here also affects where we're zooming in. So if this anchor is 0, 0, we're zooming into the left upper corner. If this anchor is 1, 1, we're zooming into the corner that's down on the right. And yeah, if we want to zoom in the middle, we just set it to 0.5, 0.5, then we're zooming in the middle and we're also rotating it from the middle or from the center. And yeah, of course, if this number gets smaller, you can see that we're zooming out. And because we use this rep mode, we can see that this, because we're using this rep mode, you can see that the flowers are just repeating. If we use clamp, it looks like this. So just the last pixel on each axis will repeat. Yeah. Maybe just before we stop, we can take a look at what happens to the actual UV coordinates we created. Okay, so you can see now we're rotating them, we're repositioning them, and we're zooming into them. Okay. 15 lines of code. I think that's not too bad. I'm gonna end this video here. Yeah, I hope you found this useful. Thank you for watching.